going to do a short video here on the RT equals D formula. You might recall that the R stands for the rate that you're traveling, and the T stands for the time that you travel, and then the D gives you the distance that you're traveling. If you know two of these, you can figure out the other one with no problem. This is typically used like this. If you are traveling at 15 miles per hour and you travel at that rate for 3 hours, then you can easily figure out how far you went. You went 15 miles each hour for 3 hours, so you went 15 times 3, which is 45 miles. Again, if you take a vacation and you are traveling 60 miles per hour and you do that for 3 hours, then how far have you traveled? 60 times 3 is 180. So now you went 180 miles. So this is a pretty straightforward formula that hopefully you're already familiar with. There are two types of problems that we use in this chapter that require this formula. The first type of problem is a chasing problem, and I usually draw it like this, where we have this person going this way and this person is following them. What I'd like to point out, however, is that both people start here at point A, and both people end over here at point B, which is where they come together. So this is when the second person finally catches up with the first person. That's what happens here at point B. And at point A, they are both just standing there waiting to get started. And then in our story, one of them leaves earlier, traveling at a certain speed. The second one leaves later, traveling at hopefully a faster speed, so that they can catch up with each other at point B. What I'd like to point out is that for these problems, you would use this formula. You would say the rate times the time of person 1 equals the rate times the time of person 2. Rate times time of person 1 equals the rate times the time of person 2. How do we know that? Well, we know that because the distance that they travel is the same. They're both starting here at point A. They chase each other for a while until they both arrive at point B, which is the point of connection. We know from our formula that if we take rate times time, we equal distance. And so we're saying that this person's distance equals this person's distance, which means that this person's rate times time equals this person's rate times time. So whenever you see a chasing type problem, you can always set it up, RT of person 1 has to equal the RT of person 2. Now, the second type of problem that we learn in this chapter is we have two people and they are running towards each other. So this person is running in this direction and this person is running in this direction. They might be traveling at different rates and they will probably travel different distances. For instance, if this person is moving very quickly and this person is moving very slowly, this person is going to get a lot farther along this distance path than this person is. Think of, here is a cheetah running this way and here is a snail gliding this way, right? The cheetah is going to do most of the work. What do we know about these two people, though, is that this right here is the total distance that has to be traveled. So now we can set up a formula that looks like this. We can say that the rate times the time of person 1 plus the rate times the time of person 2 has to equal the total distance. So rate times time, or distance of person one, to there, plus the rate times time of person two, the distance they travel, all together has to equal this total distance. And so this is the formula that we use when people are coming towards each other. I hope that makes the use of the RT equals D formula a little bit clearer. Remember, when you're working out your word problems, draw pictures and then fill in the information. It helps. Honestly, I would not steer you wrong. Okay, good luck.